Let's start one more algorithm related to the sorting. So we have know how to make arrangement of an element in the array or list, maybe ascending order or maybe descending order, using the couple of algorithms we learn like bubble sort, selection sort, right? Similarly, we have one more approach, the way you make the arrangement of the element in a given list or array. So think why we are uh, going to learn multiple approach to solve the same problem. We have a input list and we want to make the order, maybe ascending or descending. So for implementation in the Python code, we are using the multiple approach, multiple solution, bubble sort, selection sort, insertion sort. This demonstrate that in your real use case, your applications, some customer requirement come, some use case come. So while providing the implementation for this solution, you have not just only one approach to solve. Okay, you can think multiple approach to provide solution for your specific use cases. And why we think multiple approach? Question. Reason is that whenever we are going to provide solution with a multiple approach, each approach have some advantage, disadvantage, some performance. So we have to some uh, algorithm is more performant, more memory optimization. So depend upon the number of data you are testing right now. So each and every algorithm we have to compare his the complexity, maybe space wise complexity, how much storage, or you can say time complexity, how much time your algorithm will take. So if you provide the couple of solution for one use case, that's you can evaluate the time complexity graph and compare, hey, which is the best solution. Okay, so algorithm is not just only one solution for a given problem or use case, but given use case, one customer requirement, you can provide multiple solution. So algorithm is just approaches, you can say, to address a customer use case. So let's similar fashion we talk today one more approach about the arranging element. Insertion sort is a simple also comparison based sorting algorithm. So we talk whenever you are making arrangement of the element in a particular order, you have to make the comparison less than or greater than or equal to. Okay, then you have decide this element would be the first place or this element would be the first place. So couple of approaches we have understand like bubble sort. Every adjacent element you are going to comparing and swapping, comparing and swapping, comparing and swapping, comparing and swapping. Similarly, we have to learn about the selection sort where we have to pick one element and figure out at this place what is smallest value. So from this position, we have to compare this, 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 and find out which is the smallest one. Let's say this is the smallest one, then we swap at the smallest one. Similarly, we have to took the next phase, third phase. Today is the insertion sort. So here approach is a little bit more simpler than you aware. So maybe here just it's build the final sorted array one at a time, much like you might playing cards. in your hand. Whenever you maybe saw, uh, whenever people are playing the cards, okay, you receive the couple of cards and in your hand, and you are arranging in a particular order. So what happened? Whenever you receive card, you take one card first. You take one card, and again you take another card. Then you decide कि this card going to his left or going to his right. So let's say decide that this card going to the left. These two cards you receive, that is then sorted order. Again you receive another card. Then you decided this will go to the here, this will go to the here, this will go to, oh, decided you go to the here. You place this card here. So now this three card in a sorted order. You receive another card. Then you have to decide it, hey, this is the place here, place here, place here. You say, oh, this is the right place here. Okay, okay, this is the right place. Again you receive another card. Then you go to the here, no, go to the here. You decided yes. You make some space and put new card inside the middleware here. See the new place. So once you receive another card, you check the one way you comparing with this, comparing with this, comparing this. If you find that this is the right place, you have to insert after that. Let's you decide that this is the right place. After that, you are making the insertion, the new card here. This is known as inserts. You receive one card and placing. Insert card, placing. You get one card and placing in the right place, you can say. So in this case, you have just started your receiving one element you are putting here. Second element you decided go to the here or go to the second element. And this is third element. You decided go to the here, go to the here, or whatever the place, right place you are placing here. So whenever this data you inserting in the particular place, that is known as inserted. Means you receive one element, insert in the proper right place in the arrangement of the algorithm. So let's understand step by step with example. So first up, so whenever start with the second element, compare with the first element. Here logic is that whatever the you receive array, whatever the you receive array, okay. So you assume if you have one element, this is the already sorted element. So let's you compare from the second element. This is a zero element, this is the one element. You are going to comparing this with this and checking this first element in the right place or not. Okay, and insert into the correct position, and whatever this element may be going to the here or may be going to the here and relevant, then this is the two are the sorted. Similarly you have to pick the next one and decide these are going to this place or they are going to this place or this. You have to make decision and insert the right place, and you have to repeat this subsequent element, and finally you get the sorted element. So insertion sort is simply way just start with the assume first is the sorted place, and then you take the second one and compare with the first one. And if this is not right place, you make a right place. If you require, they swap them. Then you take the next element. Next element also compare with this, and so that hey, it is right place. Similarly, next element again you compare with this previous one and compare with previous one, compare with the previous one, and be check. You cannot go outside of the zero. If this is zero length, you don't go compare outside right now. Similarly, you take the next element, compare with the previous one, again compare with the previous one, again compare with the previous one, and figure out what is the right place. If let's define this is the right place, this is the right place, you have to go and insert after that this place. So look like a just a simplest way you can insert here. You can insert here and go back, go back, go back, go back and write the proper way. This is the right place. Then this element go to the right place. So this is the way you can implement the your insertion search. So for example, let's like three 53412 is the number, and let's see want to provide the approach to insertions. So what first approach started with the this is your element, and you start with the this is the first is the sorted place. You started the one. You take the three and three compare with the first one. Okay, compare three is less than five. Yes or no? Inserted before five. You say yes. Then we have to swap them. Now our element become a 3 5 4 1 2, right? Again you now this is the 2 is 0 place and 1 place you completed. Then you can start the next is a fourth place. Fourth compare 4 compare. Okay, 4 compare 4 compare with the 5. Okay, you say yes, 4 compare with the 5. That means you have to place them. Then we have to check, hey, this is the this place is the smallest one. Again you compare with this is smallest. No, this is the right place. Then you have to compare to the 4. So next element here to come up 3 4 5 and 1 2, right? Again you compare with the 1 with the 5. Is it right place? Yes. Is smallest than 1? Yes, is smaller than. Then note again compare with this one. 1 is smaller than 4. Yes, 1 is smaller than 4. Then compare this 1 is smaller than 3. Yes, compare with the smallest one. Yes, compare again. You cannot go outside of the loop. Be careful, you have to check here. You cannot go back the 0. And once you find, oh, this is the first place, you are going to place first and then 3 4 5. Similarly, you pick up the second compared to the 5. It is the smallest? Yes. We have to note that. If you compare to the year, smallest? Yes. Note that. Going compare to the smallest? Yes. Note that. Going to the compare? No, 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 no. It's not. So after that, you can place here. Whatever not condition, place here. Finally, you get the 1, 2, 3, 4, 5 in a sorted order. So while implementation, just you pick up one by one element and going back and check is the smallest or not. The smallest, then swap the value, right? So let's understand the code. So this is the smallest code, and going to understand, let's write the code first. Okay. Okay, here. Mm, okay. Okay. Not. Let's clean the. Okay. And let's take the element the same like whatever the element we had taken. 5 3 4 1 2. 5 3 4 1 2. Okay, right. So we have to write the one. Let's find function in insertion sort. Okay, you receive input array. Okay, so first things you have to take the you receive one element. Let's understand the key. Key is the your element. You take in the array of your one element. Okay, it start with the one element. Right now, this is the start with the first element. Okay, so first we have to start with the index, whatever the length of array. Okay, so you have noticed here you have received one element. Okay, and you have to going to compare one by one with the uh, just minus one element. If let's start with the number like you started one and start with the previous one, just compare to the previous one right now. So our logic say, hey, let's understand this is the I, and let's first element. So here we started from the one. Okay, and just then after that we have to let's here the loop and where I can so here let's started with this. So what we did here, let us in scenario we have our elements. So we have a 5, 3, 4, 1, 2. So we have to start loop from here. 1. Okay, we started loop from 1 to here 0, 1, 2, 3, 4. We started with the 1. I'm going to compare with the previous one. So I take another variable, previous one. I'm going to the check comparing, hey, this is the less than or greater than, right? So here say, let's compare while. So what we comparing, whenever we compare, checking the whatever the value of this position is greater than, that means key is smaller, then we have to swap them. Then we have to change, hey, the new place, this is the value you have to store them. And then say, just again minus one. So in this scenario here, let's you have a couple of number and you are just starting from here. So you are comparing with this. If this is the smallest one, then you have to change, again change, then the new value come here, again you go again compare to the here, g minus 1, again compare with this, is still smallest, you already noted the key value is smallest, again move to the here, again smallest, then move you cannot go outside of here. So this checks mention your j should be greater than or equal to, you will not compare outside of the number. Okay, in this way you can say, hey, that is the fine. So if you replace them and finally you come out the loop, if until this is the not greater than 0 and it is the value is the less key is the less than, then go outside the loop and just compare, shift the key and a specific position, whatever positions you find. So here you have to replace AF, E, and that's done. Now let's test it. Your print before let print whatever your input. This is your output. So this is my input list and comparing one by one here and check the our sorted list. So this is the loop inside the loop. Once you find that this key is a proper place. If you want to print here, every array you can check whatever the each iteration what is the value. So notice first time you pick up the key, first time you pick up the key. Let's make key, you pick up a key, okay, and you write the right place. So notice first you pick up the third value and check what is the right place. You replace the at the j position, key at the j plus 1. Okay. So notice you pick up this j and you can go replace j plus 1 right now key position, and that's at key add index. So notice you have a pickup of first position value. Even you can just write the I value. You can get the positions of I. You started with the first index. You take a key value 3 and compare. 3 is uh, 3 is less than with the key. Yes, at the 0 position. You can swap with the 0 position with the 3. Okay. So now this is your sorted. Second time you pick up the this the key 4 and comparing with the 3. Still 4 is the less than 3? No. That means you have the just go outside. This is the fail. Then go outside and place whatever the value of the j plus 1. So what is the value of j? This is the your j plus 1, like j is the fourth position. You can add the index at the 0 and then plus 1 position you can add this replace 1, right? So here so this is the our element. First time your 5 3 4 1 2 0 position, 1 position, 2 position, 3 position, 4 position. You started with the 1 position. You started the 1 position, okay, and comparing it with the previous one, okay, minus 1, comparing with the minus 1. Key is the less than with this, key the less than. If less than, then we have to change them. We have to change. If key is the less than, yes, key is the less than, and I is the greater than 0, yes. So just is shipping swapping. Similarly, you pick up the next number 4. Compare with this. Compare with this. 4. This is the value. A4 greater than. A4 is the greater than. So that means this is the key is the smallest. Yes, is smallest. We have to swap them. Then we have to take up the next number is the one. You can pick up with the one number, and one comparing with this. One is the key, and start comparing one with this 5. Comparing, yes. So this is the this place is the smallest one. This you have to swap them here. Here again comparing. This is one is smallest is the 3. Yes, comparing with this, swapping with this. Now there is no other place. Then you have to insert this number with the first place. Okay. Similarly, this is the number you can start take the element 2. It started element 2. This is the 2 is the your key. 2 is the your key. Then you can start the loop for key for minus 1. That's from previous year. So this is the value. This is the value 5. Is 5 greater than key? Yes. Then we have to shift the ahead. You can say j plus 1. Move the j. You can shift them. Again, you comparing the 4. Okay, here j minus 1. Comparing the 2. Yes, still less than. Then again swap to the plus 1 here. Then we replace here. Then again swap to the here. 2 less than 3. Yes. Swap them here. Again 2 less than, no, not less than. First loop, go here, j plus 1, this is j plus 1, and put the here. So logic is that here you are comparing this element with this, and if this is the smallest number, then shift them, then shift them, then shift them, then shift them. Finally, right place you find the right value, and finally you have to replace this value. This is the way you can implement this insertion sort. Right? It's a very simplest approach. Just start comparing each and every element, whatever the. Okay. Again, repeat same thing. Very simplest approach. You started. Let's say I want to find this is the right place or not. You have to let's understand this is the key and compare with this element. Is the right place? If not, you have to shift this number to the this place. Okay, and again you compare this with the next position. Is the right value? Is the right place? No. Just shift the next number here. Again find this with the next element. With the next element is the right place? No. Shift there. So this code just shifting to the new place, shifting to the next, shifting to the next, and you find, oh, this is the right place. So this is the right place. In finally, this is the line you are going to use the insert this key is the right place here. Now the element is the again you sorted. So this loop are just you making a space. What is the right place? Here you are finding the proper place where we have to put the specific key you have to input receive. And finally, this is the line where you are actually replacing, inserting the new value. So before inserting the right place, you need here space. Those space are make the this loop. So this is the simplest code where we are able to sort the data. So the same code here mentioned we have to start loop from 1 to length and get the key value and start comparing key is the still less than just shifting to the next value. The same value is shift to the next. So just we are making moving one more ahead, moving one more. Why? Because the right place we have to insert new value, then we have to write a blank space for that. And this is the code where you are putting the specific key at the right position. Okay. This code are just moving all the greatest number with the key in the one position ahead, right now, so that this key can be inserted in the right place. This is known as a insertion sort. So this is the very simplest approach, and just you try to write the code and play with example, and you feel uh, feel comfortable to writing algorithm in the Python. Until you are not writing a code and understanding the flow with example, uh, you will not feel more comfortable in the coding part. So for the coding part, you write the code, try the code, and understand one by one loop. Okay, so like this is the way every steps what is happening. If every step here, every step what is the happening. One by one steps, you apply the some print, some logging, understand the value one by one. They are just placing the value. Even every steps you can try to understand here right now. And once done, just you have to comment out the data, and you have to finally check, hey, this is my input and this is my output, and nothing will print right now. So this is the way you can do the practice. Write the code and debug the code, apply the print, apply paper pens, do dry run, how its code run. Our objective is that we understand the very basics of Python, how loop, how break, why condition. If you not writing condition here, then what happen, what is the end. So these are the things you do the practice. While practicing, you feel comfortable, and now you are able to implement any algorithm, any use case if you feel comfortable to writing. These are the smallest approach. So that's for the day. Thank you.